Today's lesson is on parallel lines cut by a transversal. Good. So we're going to go ahead and use our diagram up here to go ahead and solve and answer any questions we have about our new vocabulary words. So you want to make sure you draw that in your notebook and your notes as well. So the first word we're going to go ahead and talk about is transversal. It's a line intersecting two or more other lines. So in this case, our line T is our transversal. Our line K and M by these two symbols are parallel. Okay. And that line T is cutting through it. It's intersecting them. So we're going to go ahead and do line T. Alright, that's our transversal line. Alright, the next word we're going to go ahead and look at is corresponding angles. Corresponding angles is any pair of angles that have the same relative position at each intersection where a straight line crosses two others. Okay? So we're going to look at angle 1 up here, for example. Okay? So angle 1. Okay? And it's going to have the same relative location. Angle 1, you can see it's on the top of line K, and it's on the left-hand side of our transversal T. So it's in the upper left-hand corner. That is a very similar position to our angle 5. Okay? Which means they're going to equal each other, especially if they're parallel. You can notice how angle 5 is above line M, and it's also on the left-hand side of the transversal T, just like 1 is above K and on the left-hand side. So they are corresponding. They have relatively the same position. So 1 and 5 are equal. We can also do the same thing for angle 2. Angle 2 is a corresponding angle to angle 6. It's above K and to the right of T. This is above M and to the right of T. So it corresponds to angle 6. You can do the same thing for angle 3. It is below K, below the line, and on the left-hand side of transverse T. And then it's below M and on the left-hand side. So angle 7. And lastly, we have angle 4 and angle 8. They are relatively the same position. All right, the next word for us is, let's zoom out a little bit, alternate interior angles. These are non-adjacent interior angles that lie on opposite sides of the transversal. Okay? So our interior angles, if we look at K and M here, okay, the ones on the outside here above K are our exterior angles. The ones below M are our exterior angles. Everything in the middle here, this 3, 4, 5, and 6, those are our interior angles. They're inside, kind of trapped, I guess you could say. All right? They're in between K and M. That's why they are interior. So these are non-adjacent interior angles, and they're going to be equal as well. So the first interior angle we'll look at is angle 3. Angle 3, okay, if you compare it, the non-adjacent interior, so it's the other interior one, but it's non-adjacent, so it's not next to it. So angle 4 is next to angle 3, angle 5 is next to angle 3. Remember, it is the non-adjacent, which means it is angle 6 would be the non-adjacent. And if you look at angle 3 and angle 6, they look very, very similar. Okay, they do have the same, looks like, measurement, and they are equal to each other. The other two interiors we have is 4 and 5. And yes, those are the same way. Those are also equal. They're not adjacent, and they're on the opposite side of the line. Okay. Same thing goes for our, zoom out. Next is our non-adjacent exterior angles that lie on opposite sides of the transversal. So these are alternate exterior. So now we're going to look at exterior 1, 2, 7, and 8. They're on the outside of K and M. So we can say angle 1 is going to be on the opposite side of the transversal line, okay? And it's the other exterior. It's non-adjacent as well. So that would be angle M. And you can see they look very similar. Same is going to go for angle 2 and angle 7. They look very similar. They're opposite sides of the transversal line, and they're on the exterior. And then lastly we have is same side interior angles. These lie on the same side of the transversal between the other two lines. So again, we have our interior angles of 3, 5, 4, and 6, and they're going to be on the same side.
271 to Conco 271.
So angle 3 has the same interior side as angle 5. So angle 3, they're not going to be equal though. These actually add up, okay? I'm going to say and. Let's get rid of this. I'm going to say angle 3 and angle 5. And then we're going to say angle 4 and angle 6. Okay? And these actually add up to 180 degrees. Okay, as long as these lines up here are parallel, your 4 and 6 are going to add up to 180 degrees. 3 and 5 add up to 180 degrees. Okay? Alright, so there is our new vocabulary for you. So we're going to go ahead and use that to solve a few problems. Alright, so here's our diagram here. And we're going to use this for your the next part of your video as well. So keep that in mind. So if you want to go ahead and draw this so we use it, that's fine too. So AB and CD are parallel. That's our parallel lines here. AB, CD, they're parallel. And again, this figure is not drawn to scale. Okay. So example 1 has measure 1 reading 105. All right. If measure 1 is 105, what is the measure of angle 5? And what I can tell about these is that these are corresponding angles. Okay, they have the same relative position. Angle 1 is above line A and B, and it's to the left of our transversal E. Angle 5 is above C and D, and it's also to the left. So they are actually equal. So measurement of angle 5 is actually equal to 105 degrees. Okay, and I'm going to actually write corresponding also. Make sure I label how I got to that. Example 2. Measurement of angle 4 is equal to 4x, and the measurement of angle 5 is equal to 3x plus 5. Find the value of x in the measures. Okay? I'm not going to go ahead and use any values for my example 1. This is going to be a completely different question, just so you know. So angle 4 and angle 5, before I even begin with those, if I look at these, I'll notice that they are alternate interior angles. And I know that alternate interior angles are actually equal to each other. So my measurement of angle 4, which is 4x, should equal the measurement of my angle 5, which is 3x plus 5. Okay? So I'm going to go ahead and solve that. Subtract by 3x on both sides, and I actually get a value of x is equal to 5. I'm going to go ahead then plug that in. So measurement of angle 4 is equal to 4x, which is equal to 4 times 5, which is equal to 20. And then the measurement of angle 5 is 3x plus 5, which is actually 3 times 5 plus 5. And that 3 times 5 is 15, plus another 5 is 20. So obviously 4 and 5 obviously are obtuse angles in this picture. So yes, I understand that they wouldn't be 20, but if we use these equations, then yes, they would be 20. That's why we have this statement here, the figures are not drawn to scale. But we would make sure they're equal. And I'm going to go ahead and also write down that they are alternate interior angles. I always want to make sure to include why I know that they're equal. Give a reason why. Okay? So what I'd like to go ahead and do right now for the you try part is you're going to go ahead and answer these statements right here. You're going to use the diagram from above that I discussed, the one I just used right here. Okay? Remember, each question is different from one to the other, so make sure you keep that into account when you do numbers 5, 6, and 7. Let's go ahead and zoom out a little bit here so we can discuss it. Okay. All right. So number 1 has, from the diagram above, name 2 pairs of corresponding angles. You should have gotten that 3 and 7, 1 and 5, 2 and 6, and 4 and 8. From the diagram above, name the alternate interior angles. You should have gotten that 3 and 6, and 4 and 5. Then you had alternate exterior. You should have gotten 1 and 8, and then 2 and 7. And we have the same side interior angles. We have 3 and 5, and then 4 and 6. Okay? And then we move on to number 5. It says, given that the measurement of angle 7 is 70 degrees, find the measure of many of the other angles as possible. And you can actually find the measurement of all the other angles. Okay? So I started with angle 8. I said that they were supplementary. Then I went on to angle 3, and I said that these were corresponding angles. Right? Then I went to angle 6, and I said that these were vertical. And I went to angle 5, and I said that they're supplementary right here. And I went to angle 2, and I said that they are alternate exterior angles, and those are equal. And I went to angle 4 and said that they're alternate interior angles from angle 5. I already knew what 5 was, so that's how I could figure that out. And then lastly was angle 1, and I said that it is a supplementary to angle 3, which I already knew was 70. And you notice how there's a little bit of a pattern here. It's just 110, 70, 110, 70, 70, 110, 70, 110. So a lot of the angles are equal to each other. You just have to make sure you know how to get to each one of them. Alright, so using the same method here, go ahead and answer question 6. We have given that the measurement of angle 3 is 2x plus 1, and the measurement of angle 1 is 4x minus 1. Find the value of x. So let's go ahead and look at where 1 and 3 are. 1 and 3 are actually supplementary. So I went ahead and took both of these and added them together to be 180 degrees. Found an x value of 30 degrees, and giving me angle 3 is 61 and angle 1 is 119. Yes, it does check out. And then lastly we had measurement of angle 4 and measurement of angle 5. I said that these are alternate interior angles, and I know that those are equal. So I went ahead and created my equation to make the two angles equal, and I got an x value of 34. I went ahead and checked just to make it sure that they were both 134 by plugging it in.